OK, so as a quick refresher, we talked about 6 steps of the TLS handshake. First, they exchange random numbers using these hello messages. Then the server sends its certificate, which tells us what the server's public key is. It doesn't tell us if this is really the server, but it does give us confidence for what the server's public key is supposed to be. And then the client and the server need to exchange a secret and prove the server's identity in a single step. So this step achieves both of those goals. You can either achieve those goals using RSA by having the client encrypt a secret with the server's public key, send it to the server, and challenge the server to decrypt the secret. That's one way to do it. Or you could run Diffie-Hellman key exchange to get a secret. And the challenge is added by having the server sign its half of the Diffie-Hellman key exchange. Both of these achieve the same goal of giving the client and the server a shared secret and proving the server's identity. Then in step 4, both the client and the server derive symmetric keys using the 2 random values and the pre-master secret from the previous step. They do this independently and offline. Then they exchange MACs just to double check that everything sent over the channel so far has not been tampered with. And finally, they're ready to send messages using encryption and MAC with those symmetric keys that they derived. So that's the whole handshake. Now we can go back and check whether this handshake achieves the 3 goals that we talked about. Remember, there was confidentiality, integrity, and authenticity. So let's check if all 3 of those have been satisfied. So here we start with authenticity. Remember that in TLS, our goal is to make sure that the server is really the server and not some impersonator. So you can try and think through those 6 steps and try and focus on which of those steps achieves the goals that we talked about. So here we're showing all 6 of the steps, I guess except for the MAC exchange. And we can focus on steps 2 and 3 for why we're talking to the legitimate server. So in step 2, you gain confidence for what the server's public key is. This certificate is signed by some third party that you trust. And since you trust that third party, you know for sure that this is the server's public key. You don't really know who sent it to you. At this point, it could have been the attacker sending you the server's public key. The public key is a public value. Anybody can send this certificate. But hopefully, this is the server's public key. And the signature gives you confidence that this is the server's public key. Now, that's not enough to know that this is really the server. Once again, anybody could have sent that public key. But step 3 is where we really get confidence that this is the server. In the Diffie-Hellman version, the server signs its half of the Diffie-Hellman key exchange using its corresponding private key. And if you're the client, you can then use that correct public key from earlier to verify this signature. And if it checks out, you know for sure that this is really the server. Nobody else could have signed this message and sent it to you. If this was some impersonator, they wouldn't have the server's private key, so they wouldn't be able to complete this step, and you would catch them because this signature would not be valid. So this is how you make sure you talk to the legitimate server, not some imposter. It achieves the goal that we were aiming for.